Hey everyone, this is number 6B of the 2018 FRQ, and we are going back to that same question stem of a differential equation given, dy dx equals 1/3 x times the quantity y minus 2 squared. Part B says that y equals f of x is the solution to the given differential equation with initial condition f of 1 equals 0. This question is asking us to write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f of 0.7. So they are asking you for the equation of a tangent line, and you want to think about what are the things that you need in order to write the equation of a tangent line. And there are three things: x, y, and slope. We're writing an equation for the line tangent to the graph of y equals f of x. So the x value they give you is x equals 1. What is the y value of the f of x function when x is equal to 1? What is the y value? So that is given here, that when x is 1, the y value or the output is 0. And then the last thing we need for the slope of the tangent line is the same thing as what? It's the same thing as the derivative. So that is given, dy dx, that is given to you. So they give you the derivative, which is the same as the slope of the tangent line, and we're writing the equation of the tangent line, so we need that slope. From here, the question is, what are you going to do with that derivative? And you are going to take the x value and take the y value and plug it into the derivative in order to get the numerical slope of that tangent line. So I'm going to use this notation that we've seen a couple times. It's a little bit tricky, and it's not required, but you have seen it in class, so I want to just point it out here. So that dy dx, that vertical line, that x comma y is equal to 1 comma 0. So the x and the y value are 1 and 0. And that notation is saying that you're plugging in 1 and 0 for x and y, respectively. And then you just go ahead and do that. So 1/3 x is 1, y is 0, minus 2 squared. And then to simplify that, 1/3 times 1 is 1/3, 0 minus 2, negative 2 squared. And then you have negative 2 squared, which is 4, and you get 4/3 is the slope of the tangent line. Okay, so let's go back and see this question. Write an equation for the tangent line. So the equation of the line, let me just zoom out a little bit. The equation of the line, you have your x value, you have your y value, and you have your slope of the tangent line, or the derivative. So y minus y1 equals mx minus x1. And I'm going to just say y minus 0 is just y. So that is the slope, that is the equation of the tangent line to f of x at x equals 1. And it says use your equation to approximate f of 0.7. And there's a lot of conversation we can have around, like, why does this make sense? There's a lot of stuff that we'll look at the end of the video really quickly, but just in terms of what is the next step, they want you to use that equation to approximate f of 0.7. So what are we going to do with the 0.7? We would plug that in as your x value. So f of 0.7 is asking what is the output or the y value when x is 0.7. So all you have to do is plug in 0.7 for x. And you actually are allowed to stop right there, especially if you were nervous about doing that math without a calculator. You can be done right now. If you wanted to simplify, I really recommend thinking about it as money. So like this is 70 cents minus $1. And that is negative 30 cents, right? You could do this multiplication. Actually, you could do this. Negative 0.3 cut in 3 pieces would be negative 0.1. or that's like 30 cents divided by 3 is like as a dime. 4 times negative 0.1, that's like a dime times 4, so that's 40 cents, but it's negative. But what we always say at this point is like, if you're not confident in that, you can just stop. I also did 4 times 0.3 and then divided by 3, but really, this is completely fine, and you can just stop there. So let's look at that rubric. The first point was the equation of the tangent line. So that was getting the equation of that tangent line. You can see the work leading up to that. There's that notation. When you plug in 1 and 0 to the derivative, you get 4/3. That was our slope. They wrote it out in a sentence. An equation for the line tangent to the graph of y equals f of x at x equals 1 is, and there's the equation of the line. You don't have to write all that. They're going to just be looking for this. Okay, and then the last point, the second point, is the approximation. And like we said, you're allowed to leave it and not simplify to negative 0.4. The final thing I wanted to say was just the idea behind this, quickly, that if you have some graph, and what point are we doing? X equals 1. So let's say x equals 1 is here. The idea was that if you take x equals 1 and you write an equation of the tangent line at x equals 1, that you could take some point, in this case it was 0.7, and you could plug it into the tangent line. And the output at that point is really close to the actual output on the graph, because 0.7 is really close to 1, so then the y values are also going to be really close together. So you plug the point into the tangent line, but it's giving you an approximation for the output of the graph, just because the graph and the tangent line are really close to each other, near x equals 1. Again, I don't think any of that thought is required. I think even if you forget, this is called linearization, even if you forget that, what it's called, you forget that idea, you're still going to know what to do, because you know the equation of a tangent line is x, y, and slope. They gave you x and y. You know that the derivative is the same thing as the slope of the tangent line, which they give you that derivative and you plug in. Like, you're going to be fine getting that equation of the line. And then f of 0.7, I think we know that means that x is 0.7 and I should plug it in. And you don't have to do any of that other thinking about why does this work? Why does it make sense? What is it called? And you can still, you still know the steps to take. Okay, that is it for this question. Great job.